I have a line segment here with a slope of 2/5, and what I want to do is draw a line segment that's parallel to this segment. So I'm just going to take a random starting point, and you know from your discussion and investigation in class that if two lines are parallel, if they never meet, if they have the same steepness, makes sense, they should have the same slope. So if I start at this red point and I rise 2 and run 5, I'm going to land there. You can see visually that those two segments look parallel to one another. Alright, now let's talk about the issue of perpendicular. If two segments are perpendicular to one another, their slopes obviously aren't the same. They must be opposite in sign, because if one line was rising, the other line would have to be falling. So there is one relationship in terms of their slopes. Let's take a look back at the blue line again. You remember from some of your earlier grades that if we asked you to draw a 90-degree rotation of this segment about this point, what ends up happening is that the coordinates end up getting reversed. Just try to imagine that we're going to take this segment, and in fact I'm going to clone it. There we are. And I'm just going to do a rough 90-degree rotation, counterclockwise. Okay, so there's 90 degrees approximately. And if you just look at where the point ends up, and if you measure that in terms of slope, if you start here and go a rise of 5 and a run backwards of 2, you get a slope of a perpendicular segment that's -5/2. And that should hopefully remind you and be another justification, or a feeling at least, as to the relationship between the slope of an original segment and a perpendicular segment. The slopes are opposite in sign and reciprocals of one another. And so we came up with these two generalizations. If two line segments are parallel, their slopes are the same. And if two line segments are perpendicular, then their slopes are opposite reciprocals of one another. So if you have a slope of 2/5, then a slope segment parallel will be 2/5, and perpendicular will be the flip of that with the opposite sign. If you had a slope of 4 on a given segment, then the parallel segment has the same slope, 4, and the perpendicular segment has the reciprocal of 4, 1/4, made negative. If you had a slope of -3/2, then the parallel segment would have a slope of -3/2, and the perpendicular segment would have a slope of 2/3, switch the sign positive. So if line 1 is parallel to line 2, then slope 1 is equal to slope 2. It's just another way to state these conclusions above. If line 1 is perpendicular to line 2, then slope 1 is the opposite reciprocal of slope 2. And another way to say this statement is to say that the two slopes, slope 1 and slope 2, multiply to -1. So if line segments are perpendicular, we can say that their slopes are negative reciprocals of one another, or their slopes multiply to -1. And you can check this out above. An original slope and a perpendicular slope multiply to -1. An original slope and a perpendicular slope multiply to -1.